Good morning, good afternoon, and welcome to the webinar on solar power irrigation systems for small-scale farmers in Mozambique, status and opportunities for the sector. My name is Fernanda Winter, your moderator for today. This webinar is organized by Energypedia in collaboration with AMER and is possible thanks to the GIZ program Green People's Energy, GBE, funded by the German Corporation through the German Federal Ministry for Economic Cooperation and Development, BMZ. The aim of this webinar is to provide a snapshot of the market for SPIS in Mozambique and also introduce the technical concepts related to solar irrigation. We do hope you enjoy it and find it useful. Today's webinar is part of an ongoing series on the technical aspects and market status of different renewable energy technologies in Mozambique to improve energy access. We started with solar home systems back in October and will continue next year with other technologies. All information on these topics can be found in Energypedia's Mozambique Off-grid Knowledge Hub. So for the housekeeping, this webinar is being recorded and the documentation and the recording will be available in Energypedia by tomorrow for all attendees. More information on today's webinar and all our panelists can be found in the link. This webinar is organized in dual language, in Portuguese and English. So in case you are in the English presentation and you wish to keep watching in Portuguese, please click on the link in the welcome message in the chat and close the GoToWebinar software. Once you click the link, a pop-up window will open. Please select Only Listen and you will be able to start listening to the webinar in Portuguese. Now, for the housekeeping rules, I would like to tell all our attendees that they will remain muted for the whole webinar. If you are watching this webinar in GoToWebinar, in order to ask a question, simply click on the Questions tab and type your question in the box. For our viewers watching in Portuguese in the Big Blue Button platform, please write your question in the chat. Please also indicate to which speaker you want to direct your question or if it's for all speakers. You can share your questions in either English and Portuguese. On today's agenda, we have two presentations from experts from Practica Foundation. First, it will be about the technical considerations for planning and solar power irrigation systems, and the second will be an overview of the market insights for small-scale solar-powered irrigation systems in Mozambique. These presentations will be followed by an overview of the tools and resources in Energypedia for SPIS planning. To close the webinar, we will have a Q&A session with all three experts where we will address the questions you sent us via the question tab or the chat. Now, to kickstart today's webinar, we would like to ask you to answer the following poll. I will launch the poll in a second. So I would like to know what is your level of understanding of solar irrigation, if it's a beginner level, intermediate, or expert. I will give you some more seconds to answer, and I will share the results with you. Thank you to all voters. So 44% of the speakers in the English platform say it's beginner, 38% intermediate, and 18% expert. So we're happy to see that there's different levels of understanding in the topic. And for our speakers in the Portuguese channel, we have 29% that are beginners, 57% that are intermediate, and 14% that are expert. So thank you very much for your voting. And we do hope that you all find this webinar insightful regardless of your level of knowledge or experience in the topic. Thank you very much. Now, to kickstart the conversation, I would like to present our first speaker, Marion. She has developed a range of tools to provide practical and accessible information to farmers and technicians on solar power irrigation. Marion will give us an introduction to the technical consideration of SPIS planning. And Marion, the floor is yours. If you can turn on your camera.
Good morning.
And you will be able to share your screen now. Thank you.
Good morning, everyone. So as Fernanda mentioned, my name is Marion and I work for Practica. I will be presenting now some technical consideration when planning for a solar-powered irrigation system. We came up with the idea for this presentation because we have been working on many projects in Mozambique and in the rest of Africa with a large diversity of partners, but we noticed that there are some recurring mistakes that are being made in the design of solar-powered irrigation systems, which can sometimes lead to their failure. It's not like everybody's making these mistakes all the time, but we have seen them happening several times. So now I would like to give you some tools to avoid making these mistakes and hopefully increasing the chances of success of designing solar-powered irrigation systems. First of all, I wanted to agree together on the definition of what is a solar-powered irrigation system. So I think I won't be teaching you anything new. SPIS stands for solar-powered irrigation system. What do we use it for? We use it to bring the water from a source to the field, to the plants, sorry, thanks to solar powered. And I came up with my own definition of what could be a solar powered irrigation system. And it is the following: a set of technologies working together as part of an interconnecting network, which is basically a system, to bring water from a source to plants thanks to solar power. So now that we know what is a system, what do we need to have it, to make it? Well, we need a water source, we need a pump, a solar generator, which in most cases, if not all the time, will be solar panels, a conveyance system, which is basically the piping system that will bring the water from one element to the other, and an application system, which will be the technology that distributes the water between the plants, trying to give approximately the same quantity of water to each plant. I just wanted to point out that manual application, like for example with watering cans, is also considered to be an application system. Now, as you can expect, for each of these types of technology, there are many different models, brands, types that exist and that are available on the market. But not all of them fit with each other and not all of them will match your situation. So basically, there is no one size fits all system, and you're going to have to determine which technology fit with your context and which technologies fit with each other. But how to do that? How to select the right technology? Well, I wanted to start by giving you an example of what is commonly done, but what you should not do. It happens very often that you want to start with a pump. It can make sense in the sense that the pump can be considered a central element of your system. It is what allows to bring the water up and horizontally in the system. It is literally like what generates the power, and without the pump, well, you can have all the other elements, you won't have a system. Most of the time, it's also the most expensive piece of hardware in your system. So yeah, it might seem logical. So if you start like that, what's going to happen is that most of the time you're going to think, okay, I need a pump. I will go on the market and I will see what's available. And then you will realize that there are many different types of pumps that exist, some that can pump deeper, some that can bring a larger discharge. So you're going to need to narrow it down. Now, a very natural way when you're not familiar with designing solar irrigation system, a very natural way of narrowing it down will be to calculate the water that your fields need. So you will estimate the water needed by your crop, and you will determine the area. And thanks to that, if you also take into account the losses in your system, you will be able to come up with a required pump flow. Let's say you come up with a required pump flow of 8 cubic meters per hour. Then you will go back to your distributor, to the market, and you will check the pumps and you will check the characteristics of the pumps. Only most of the time on the pumps, what is indicated is the maximum flow that the pump can provide. So you will want to take a little bit of margin. And for instance, you're going to say, okay, I need 8 cubic meters per hour. So this pump can provide me 12 cubic meters per hour. It seems like a good choice. There is 4 cubic meters of margin, like 50%. Well, why wouldn't it work? Well, the truth is there are many reasons why it wouldn't work. And I'm going to explain now 2 of the mistakes that you made and 2 of the reasons why it might not work. The first thing is that you looked at the needs of your crops, the needs of your field, but you did not look at your water source and at the water that was available in your water source. So if you're pumping water from a river that never dry or a lake, well, then most likely you won't have this problem. But if you're using a well or a borehole, well, when you pump water out of it, the well needs to recharge. There needs to be water flowing back in. And if the water that flows back in is slower than the water that you pump, well, your well will dry out. And no matter which pump you have, you won't be able to irrigate the whole field that you planned for. So most likely it means also that you used a pump that is too big compared to the area that you will be able to irrigate. Maybe even your application system will be too big. So you basically run the risk of oversizing your system and also of not making an efficient use of the resource. Now, the second thing is that you looked at the maximum flow of what the pump can provide. But what you need to know is that the flow of the pump varies according to the depth of the water, the height of your system, the type of application system you're using, and even the conveyance pipes that you're using. So the same pump, if it's placed in a source where the water is at 3 meter depth, or in a source where the water is at 8 meter depth, it won't be able to provide the same flow. So each pump has a specific own curve, like the one I'm showing now, which shows a relationship between the flow that the pump can provide, the pump discharge here, and what we call the head, which is basically the water depth, the height, the pressure that you need to use your application system, and the friction in all the pipes. So you can see that there are 2 curves. The first curve in green is the curve if you use 1 solar panel of 360 watt peak. And the other curve is if you use 2 solar panels of this power. Obviously, with 2 solar panels, you will be able to have more discharge. But you can see in this curve that, especially at the beginning, as the head increases, the flow reduces very fast. So you might indeed have a maximum flow of about 12 cubic meter per hour. But if your head is about 10 meters, for instance, you won't be able to have your 8 cubic meter per hour. So now, hopefully, you understood more why it is a mistake. I think it was important that I started by presenting why you should not do that, because it's important to understand the reasons why these mistakes are being made and why they should not be made, because it's a very natural way of thinking, I think, but you should always start at the water source. So that leads me to the next slide. You should always start by collecting information on what you have, and you should always start by the water source. You will be collecting information on the water source, the field, the application system, and the conveyance. But in your system, the most limiting factor will always be your water source, because you will be able to change the size of your field. You will be able to change the type of application system you're using. You will be able to change the size of your conveyance pipes. But changing your water source is almost impossible. Sometimes in certain situations, you will be able to what we call improve the water source and increase its yield, but it's costly, it's not always doable. You might not want to change the size of your field or the type of application system that you're using, because it has a certain cost and certain practical implications, but it remains possible. The water source most of the time is just a given, so you have to work around it. And that's why it should always be the starting point when you design your system. And you should always estimate the yield of the water source, meaning the volume that is available during a certain amount of time. All the other information will allow you to calculate the required pump flow, which is basically the water that is needed by your crop times the efficiency of your system. Here, I considered the efficiency of the application system because we always advise to use piped conveyance system, and then the losses are very low, so they can be neglected. But there are definitely losses in the application system because no system is always 100% efficient. And the rest of the information will be used to calculate the head. Now, the head, I have been mentioning it a few times. What is it? It is the pressure that the pump needs to overcome to bring the water up and push it horizontally in the pipes. It will be the addition in meters of the dynamic water level, the height of the system, which is basically the difference of elevation between your water source and the highest point in your system, so it can be your field or underway. The pressure that you will need to operate your application system, and the pipe friction. The pipe friction can be calculated relatively easily using online calculators. Now, once you have collected all this information and you have calculated the required pump flow and the head of your system, you can check again the pump curve of the pump you're considering to buy. I've summarized here the information that I have been telling you so far. So first of all, regarding the flow. So you calculated the required pump flow. The required pump flow is always more than the water needed by the crop, because you need to account for the losses in your application and your conveyance systems. But this same required pump flow should always be lower than the water that is available at the source. Otherwise, you're going to have a problem. So pay attention to that. Now, on the other axis is the head of the system. It's the addition of the water depth, the height, the friction losses, and the application pressure. And you come up with a total head here. Now, if I draw the points of my system, I see that I end up here. So actually, very far from the two curves I have been drawing. So even if you use more panels, I mean, there is a certain limit of panels that you can use per type of pump, you will most likely never be able to get the required pump flow that you have with this pump at the head of your system. So you can either drastically reduce the size of your fields or make improvement and using an application system that requires less pressure and is more efficient. Or you should maybe consider another type of pump. And a solution might be a pump with this sort of curve. So here you also see that the curve is a little bit far from the points that you drew. But then it's about finding balance between the other aspects like your financial capacity and whether you have the possibility of extending the area that you want to irrigate or if it's not really an option. That leads me to my next slide, saying that it's not all. There are many other technical, commercial, financial aspects that you need to consider when buying a pump. You should never neglect the required pump flow and the head of your system, but there is many more choices that you need to make. For instance, you will have to choose between a suction and a lifting pump. Using a suction pump is not always possible. You will have to determine the number of solar panels that you need. According to the type of water source that you have, you won't be able to use all sorts of pumps. Like for instance, if you have a borehole, some pumps are too big and will never fit in there. If your water source has some sandy water in it, not all the pumps will work in there. You need to determine whether the repairability and maintenance aspects of your pumps are important or not. There are also some commercial factors, like what are the technologies and the services associated with these technologies that are available locally? Is a warranty important for you? I put the financial aspect in third, but actually they're very important, especially considering that solar irrigation technologies are expensive. And there are also social aspects that you want to consider, like the risk of theft. How easy will it be to secure your pumps or in your other technologies? How easy is it to transport them? For instance, if you want to share them with a neighbor and he irrigates one day and you irrigate the other day, the pump needs to be transportable. So, and this is a non-exhaustive list. I'm sure you can find many other factors. It also depends on your personal choices and situation. But always keep in mind that choosing technologies for a solar-powered irrigation system is not a decision to take lightly, and you should always have a very good overview of your situation and what you want to achieve before making any investment. So now my presentation is finished. I will leave you with my colleague Berry, who will present you the solar irrigation market in Mozambique. And Renisha will present you the tool and resources available at Energypedia. But I just wanted to mention that I gave you in a snapshot of 15 minutes how is it to design a solar-powered irrigation system. But we have been providing trainings on this topic of several days. We have curriculums available for technicians, end users, and teachers. And we also have a certain amount of training tools, very didactical to make the learning very practical. So if you're interested, please visit our website and contact us through the contact section or send us an email at info@practica.org. Thank you for your attention.
Thank you so much, Marian. This presentation was very informative and it was very clear. And as you said, it's important to find the balance of all considerations for your field and your system to select the appropriate pump and all the components. So thank you very much. Now I would like to introduce our next speaker. So first I will take control. So our next speaker of today is Barry. Barry van der Poel. Barry is a specialist on farmer-led irrigation with 10 years of experience in Mozambique and realized a market study on solar irrigation pumps, which he will present during this webinar. So Barry, if you could show yourself, the floor is yours. I will give you control in a second so you can share your screen. One second. Yes, you can share your screen now. Thank you.
Yes, good morning, everyone. I think it's working now. So my name is Barry van der Poel. I'm working for Practica Foundation, just like Marion, and I'm going to present the results of the market study on solar irrigation pumps in Mozambique that we implemented this year with support from GIZ and the Green People's Energy Program. Let me just maximize the presentation before we start. All right, I hope everybody is seeing the presentation now. I was looking through the attendees and I noticed that many of you have actually contributed to the survey, responded to our questions, and therefore made this study possible. So I would like to thank all of you who participated in the survey. And I'm glad we could use this webinar to share the results with you, since you've all taken time to go through this rather lengthy questionnaire at times. So thank you very much for that. Oh, what's happening? There we go. So we have been working on solar powered irrigation for many years, and we see an increased interest because of the impact it has on food security, water access, energy, and climate. It can be a very effective strategy to reduce CO2 reduction, to reduce CO2 emission. A solar pump emits about 97% less CO2 than diesel pumps in a life cycle analysis that includes the fabrication of the pumps. On a farmer level, there's also clear advantages. It can reduce the out-of-pocket costs for farmers in terms of labor or fuel. And submersible solar pumps, which is the case for most solar pumps, they allow farmers to access groundwater that is too deep for fuel pumps. Now, we've been working in quite a number of countries, and we see that the growth, the sustainability, the demand really depends on the country and the physical, the socioeconomic, commercial, and institutional landscape. The countries where solar powered irrigation is most successful are actually the countries where solar pumps have been heavily subsidized, like some states in India, but also Morocco and other countries. That's why it's always necessary to do a specific country study to assess the scope and potential for solar powered irrigation systems. And that's what we did in Mozambique earlier this year. So the objective of this study was to analyze the current technologies that are available in terms of off-grid solar powered irrigation technologies and the promotion strategies that are in place targeting small-scale enterprise farmers with less than 2 hectares in Mozambique. And we intended to use this information to formulate recommendations for the further promotion and acceleration of this market development. We started with a stakeholder mapping to get to know all the actors that are working on solar powered irrigation in Mozambique. We started with the manufacturers and asked them, who are your contacts in Mozambique, who are your clients, and so on. And that's how we assembled quite a list of of organizations, many of whom are present here, so that's nice. We contacted those suppliers, governments and NGOs, and asked them to fill in online surveys about the technologies, but also the promotion mechanism. And finally, the results were cross-checked and further discussed with a number of key experts who also helped to formulate recommendations. So as you can see, overall, 52 surveys were sent and 21 have been responded to. So starting at everywhere where you see chapter 1, this is information coming from the survey with the private sector, the suppliers. We noticed that quite a lot of brands are already available in Mozambique, as you can see on the left side. Known brands such as Lawrence and Grundfos, but also less known, mainly Asian brands. A few of them have confirmed that they are not yet available in Mozambique, such as many Sun Culture and Daylive that are well known, and to some others we couldn't find out. You see that the distributors are the bigger ones that have been selling over 100 pumps per year for a period of at least 3 years, whereas many others are actually available on retail basis, with the suppliers selling about 2 to 25 pumps a year. So it's a different order of magnitude. Asking these suppliers about the water source that their pumps are used with, we found that deep boreholes and rivers are the main water sources used with solar pumps. A big concern here is that most farmers do not have access to either deep boreholes or rivers. So this is something to take into account when we want to scale solar powered irrigation pumps. This is just an overview. I'm not going to read it all, but these are some of the specific models, prices, and capacities of pumps that are available in Mozambique. The report will be available on Energypedia, and you can also find the links to all the suppliers in Mozambique and the manufacturers of these pumps to find all the detailed information that you need. This is a snapshot from the beginning of this year, but I must also warn you, the market is developing rapidly, so information may already be outdated at this moment. So it's good to keep on checking the suppliers' offer through the links that are available in the report. An important remark I'd like to make is that it's very difficult to compare prices of different solar pumps and models. On the one hand, because of the capacity, as Marion already explained, you cannot compare pumps if you don't know the daily water need and the total head that it is based on. Next to this, there's also large differences in the components that are included. So the prices communicated by the suppliers did or did not include solar panels, frames, cables, installation, transport, and so on. So you need to ask a lot more questions if you really want to compare the prices of different technical options and different pumps. Also, the warranty varies. Most common warranty provided by suppliers is about 1 year. There's one providing 3 years, 2 actually, and some are actually unknown. We can see the same for the irrigation systems. Most providers come with drip systems that have calculated per hectare quite comparable price, or not more than a 20% difference, around 5,000 euros per hectare. Spray tubes are a very different case. I must say this price is very low that we see here, so that has to do with a subsidy. But overall, it is a lot cheaper solution compared to drip irrigation. That is not yet widely available in Mozambique, only in Chimoio at the moment. And here again, we also see differences in the components that are included when the prices are communicated. So again, important to ask whether the price covers installation, transport, spare parts, and so on. The suppliers indicated that the main markets, the sector with the highest potential for them is either small-scale private irrigation or communal drinking water supply in rural areas, as you can see over here. We see that over the past 3-4 years, the number of solar pumps sold in Mozambique have increased steadily. You need to read from right to left here to get it well. And if you look at the total numbers from all the companies added up, you see an increase of 5 to 10%, and I expect this increase will continue. These are the pumps sold by suppliers in Mozambique. I asked everyone a question about spare parts and where they are stored, and we see that this is very different from one company to another. It had a direct relation with the average downtime. So the time between farmers reporting a failure of the pump and the moment the company could repair it. So the average downtime was 9 days, which in the dry season could lead to a lost harvest if a farmer cannot find another pump that he can use in the meanwhile. So that's problematic. However, we found that those companies that store their spare parts at district level manage to intervene in 2 to 3 days, whereas those who have to import it need at least 15 days or more. So this is a direct relation and shows the merits of having more local or regional branches in the country. About finance solutions offered by the suppliers, we noticed that most suppliers cannot provide pumps on credit, even though farmers would need that, most of them. Some do, only to trusted and known customers or to clients with a high salary, but that's of course not what most farmers can make use of. And the big problem is that the companies don't have enough cash flow to pre-finance all the pumps, which would be a very big investment if they need to do so by themselves. So the solution, according to suppliers, is to establish a bank facility with low credit rates for farmers to purchase the pumps, or to have a project to subsidy and reduce the cost, to subsidize and reduce the costs. So this chapter is about the support initiatives by the government and NGOs. So the results you see here follow from the surveys with those organizations. We see that most of the NGOs target farmers that are irrigating manually or having rain-fed production systems. There's a dominance in central Mozambique, and that mainly has to do with the availability of funds after the Idai cyclone that became available for development in that area. So the main farmer type supported are again smallholder private farms of less than 1 hectare. And when comparing, it's difficult to compare, of course, the cost of different projects. But if we just looked roughly at the total cost of the equipment, so that means the solar pumps and the irrigation systems, and the total area covered, we saw that, well, the average cost per hectare varied from one project to another, but only by a factor 2 to 3, not more. Some of them, some NGOs did a cost-benefit analysis, and they found a return on investment of the solar-powered pumps in 2 to 3 years. So after 2 to 3 years of harvest, farmers would recover the investment. About half of the projects by NGOs and governments donated the pumps, either fully or with an in-kind contribution, whereas the other half asked some kind of financial contribution from farmers, but most of the time not the biggest part of the cost. The main reason for NGOs and governments to engage in solar irrigation is environmental sustainability, number 1, followed by reducing farmer production cost. Unfortunately, the large demand by farmers was mentioned by none of them, which is understandable because the large demand by farmers is not there yet. A lot needs to happen in terms of pricing, accessibility and promotion to increase that. We'll talk about that later on for the recommendations. According to institutions, the challenges of solar irrigation are related mainly to technology, finance, and the supply chain. And we'll discuss them one by one. So a number of technical barriers, as already highlighted by Marion, come with the introduction of solar irrigation pumps. Starting with the available water sources, to increase the market, we need to go beyond rivers and deep boreholes and also look, for example, at shallow wells or other systems. Solar pumps have a limited capacity compared to fuel pumps, which is why it's difficult actually to promote solar pumps to users of those kind of pumps. Of course, higher capacity solar pumps exist. You've seen examples in the table, but we should realize that there's a direct relation between the capacity of the pump, the energy you need, and the number of panels, and the cost of the system. So of course, bigger is possible, but it will be more expensive. There is a lack of optimal irrigation technologies for solar-powered irrigation. Most farmers are still used to using furrows, which is not an optimal system compared to the small flow output of solar pumps. Drip systems are widely available, but the cost is high and alternatives are very scarce. The risk of theft was mentioned by various projects, so there is a need for either a portable solution or protection. And repairs are challenging. Maintenance is not frequent for solar-powered pumps compared to fuel pumps, but when there is a need for repair, it is challenging because there's limited knowledge and capacity locally. The installation was often done by suppliers. So again, local technicians may not have been involved. And then, of course, it's difficult to fix the problem. Spare parts are not widely available in most cases. And this surprised me, only 40% of the suppliers actually provide training to the users on operation and maintenance. Well, there's a quick win to be made, I think, in terms of the sustainability of the solar-powered irrigation systems. This is one picture I found from one of the projects. So the technical barrier, of course, here is that if you have a big field, this will take you a lot of time compared to fuel-powered pumps. There's also, going from the technical barriers to the commercial barriers, we see that the private sector is very divided in regards to the demand of solar pumps. Some consider it actually very low and others very high. There's no median. But still, 44% of the suppliers is planning to invest a lot in solar pumps in the near future, which may have to do with the availability of external funds as well. The main challenges are the lack of knowledge and especially finance, according to 64% of the suppliers that responded to the questionnaire. The government launches tenders, sometimes big ones, for solar-powered pumps, but unfortunately they are not accessible for most brands or suppliers because of all the criteria. We see that when comparing solar to other powered pumps, for example, more taxes are involved. So there is no general tax exemption for solar pumps, even though in some projects there are exemptions. There's a 7.5% import tax on solar pumps compared to a 5% one on agricultural technology, but solar irrigation pumps do not qualify as such. And there's a 17% VAT, whereas hand pumps, for example, are VAT exempted. So it seems that the solar irrigation pumps are in between, but don't benefit from any of the tax exemptions or reductions. Luckily, import problems are few. There's no shortage of foreign currency compared to some other countries. And in the harbor of Maputo, nowadays, only 2 to 3 days are needed to get the pumps out if suppliers make use of the new pre-warning system. So that's a good thing. However, the import process is still very expensive due to all kinds of charges in the importation process. which amount up to 30 to 40% of the CIF costs. And therefore, the prices of solar pumps in surrounding countries like South Africa and Zimbabwe are actually more competitive. So recommendations focus on information and training. The biggest barrier mentioned by everyone is access to finance. The cost of solar systems, at least 1,000 euros, is too high for most farmers. Access to credit is limited, with a commercial interest rate of 19.3%, and eligibility criteria by banks and MFIs that most farmers cannot fulfill. The high upfront payment or collateral that is required, and land in Mozambique doesn't count as collateral, but also the need to have a bank account, salary slips, business plans, submit online requests are all things that are not possible for most farmers, unfortunately. The suppliers prefer bank to set up bank loans, since it's the banks who have this expertise in managing credit arrangement and the suppliers don't. So a donor could, for example, sign a contract with a bank, provide a guarantee so they can provide loans at a lower interest rate. Subsidies are also recommended by suppliers, but full subsidies, no one supports it really because of the lack of ownership and real interest, which compromises use and maintenance of the systems. But partial subsidies are recommended by most actors and actually also planned for in the near future. An alternative that's not yet available in Mozambique are so-called Payasyougo solutions directly provided by the pump suppliers to the farmers without the intervention of a bank. The advantages is that often these solutions are more accessible for farmers since it requires less paperwork and business plans and so on. And that there's a big mutual interest to succeed. So if the farmers don't have a good pump and don't manage to produce a lot, they also won't be able to pay back to the supplier. And the Kenyan company Sun Culture has really developed and and upskilled this solution over time. Recommendations are to focus on these three barriers: the technical, the supply chain, and the financial part, with a big focus on the financial part. That is to focus on both partial subsidies and inclusive credit mechanisms. Actually, subsidies can be very much justified because solar pumps can serve various interests. Sorry, I can see all kind of messages coming up. And donors can provide guarantees to the financial sector or work with the private sector and the pump suppliers directly to provide pay-as-you-go solutions. Practica, with support of GIZ, will launch a call early next year because we want to make use of these recommendations to accelerate the SPIS market in Gaza province. Therefore, we will start training drilling teams, provide trainings to companies and other stakeholders. Actually, a call will follow and be published on the Energypedia website, and we'll pilot a pay-go solution for which also a tender call will be launched for companies to provide 100 solar pumps with a pay-go solution for small-scale farmers. If you want to stay up to date, you can subscribe on the Energypedia website or send me an email. Thank you very much. Hello?
Thank you very much. Thank you very much, Barry. Sorry, there was a little delay on my end. Thank you very much for your presentation. We really appreciate it. It was very informative, and it's definitely a great opportunity for PAYGO implementation. Definitely a heads up for any interested stakeholders in our audience to stay tuned for early 2022. So now I would like to remind our viewers to send your questions for the speakers via the question tab in the GoToWebinar software. And for those watching in English, sorry, this is for those watching in English. And for those watching in Portuguese, please send us your questions in the chat. And please remember to specify to whom the question is addressed. And I would also like to remind our viewers to please remain muted during the webinar. So if your microphone icon is red, that means you're muted. But if it's not red, then please click on it so you are muted. So thank you very much for that. So now I will take over one more time. And I would like to introduce our next speaker of today. That is Renisha. She is a very experienced colleague in Energypedia. She has more than 6 years of expertise in energy research, project management, and developing knowledge products in a variety of renewable energy and energy access topics. And she will now present the tools and resources for SPIS planning available in Energypedia, as well as the Mozambique Off-grid Knowledge Hub, an online platform where you can find all the relevant renewable energy information for Mozambique. So Renisha, the floor is yours if you can take over. Thank you.
Thank you so much, Fernanda. Just confirming that you can see my screen.
Yes.
And I have switched on my camera, so hopefully you can also see me.
Yes.
Perfect.
Thank you.
Great. Then good morning, good afternoon to everyone who is listening to us right now on both the English and the Portuguese channel. As Fernanda mentioned, my name is Renisha, and today I want to give you a brief introduction to the Mozambique Off-grid Knowledge Hub, which we recently launched, and also talk about resources and tools for SPS planning, building on what Marion and my colleague Barry just talked about. So without further ado, let's kickstart with my presentation for today. And for those who do not know us, Energypedia, I wanted to kickstart by giving a brief introduction about us. So Energypedia is a non-profit organization that maintains the platform www.energypedia.info. Here you can find all kinds of information related to off-grid energy, whether that be solar, hydro, wind, for developing countries' context. And along with that, you can also find resources on what are the latest events, opportunities, latest news, and everything that is happening in the off-grid energy space. So I hope you will join us. And moving towards to the topic for today, the Mozambique Off-grid Knowledge Hub. I want to kickstart this presentation by first thanking our GIZ program, Green People's Energy for Africa, for supporting us with developing this platform. So thank you a lot. And moving towards the Off-grid Knowledge Hub. So the whole concept of Energypedia is by the community for the community. That means we want to ensure that the knowledge that is available among the community, that is the experts who are listening to me right now on both the channels, is available on a centralized place and easily accessible to other experts who would like to know more about it. So we took the same concept, and that's what we used to develop Energypedia, Mozambique Energypedia Off-grid Knowledge Hub. So it is one central destination where we try to put up all curated information on RE and energy access information, and we try to focus on key technologies like solar home system, clean cooking, nanogrids, and productive use of energy. And here we brought in the motto, by the community, for the community. So that means we are hosting the platform, but we are continuously updating it by collaborating with you, the experts. So we are collaborating with you to get the latest information and work together with you to put them online on Energypedia and so on. And how exactly we do that, I'll talk about it shortly in my presentation. And along with that, the idea of the hub is also provide a space for you, the stakeholder, to share your project information, knowledge, and lessons learned. So if you haven't checked out our hub yet, my colleague will share the links to the hub in the chat shortly. And we will also share these links in a follow-up email that will go out to you today. So where you can find all the links. And if you have already seen, so on the left side of my screen, I have a screenshot of the hub in English language. On the right side, we have it in Portuguese language. And currently we are fine-tuning the Portuguese language, so that all the information is available in both English and Portuguese in dual language. So we encourage you to have a look at the hub, and if you see something that could be improved or you have any feedback for us, we greatly welcome your feedback. So please feel free to, we encourage you to reach out to us. And when I say a hub or an information center, what exactly does that mean? So if you go to the Mozambique Off-grid Knowledge Hub, you can expect information on a range of topics. So for example, that could be about the electricity situation. What does the electricity market look like? Who are the actors? That could be about the RE potential. That could be about what kind of end user financing is available on Mozambique for a company, for end users, and so on. And along with this background information, we have tried to also create curated technologies hubs where you can find information related to particular technologies. For example, the solar home system being one of that. And my colleague already mentioned that we also did a webinar on it, and all information related to solar home system markets, you'll find it there. We have also one on improved cook stoves, and the other one on productive use of energy, where the solar irrigation, the topic of today, falls into. So that's where you'll find all information. Also what Barry just talked about, his report, and all the additional information I'm going to talk about today, you'll find all of it on the productive uses of energy hub. And along with that, on the Mozambique Off-grid Hub, you can also see a range of other informations, like what are the latest news from the sector, the publication. Our co-organizer for today, Amer, has a lovely publication database, which is also linked there, the opportunities from the sector, and so on. And along with the hub, we have a lot of experts today also in the house listening to us. And what we wanted to do was really have a group where we can bring all the experts together. So that's why we have the Mozambique Off-grid Practitioners Group. And you might ask, Renisha, why we should join it. The top 3 reasons would be, so what we do with the group is every month, we also send out a monthly news from Energypedia, where you get information about what are the latest chapters or articles or resources or tools that we have developed for Mozambique. You'll get a list of all of those. For example, Barry just talked in his presentation about an upcoming tender. So once that tender is out, we will also share that information to you via the group email, which you will receive from us. Once you become a member of the group, you can also see who are the other members, and you can reach out to them. You can send them a message, network with them. We also have a discussion space where you can post in your discussions or answer questions from your fellow Energypedians. So we really encourage you to join the group, and it's very simple. All you have to do is register on Energypedia and join the group. And all the resources that I'm talking right now, I'll be sharing all of that. So I hope you'll join the group. And moving forward, to all the companies or organizations listening to us today, we also have a stakeholder database, which is again free and open source and available to everyone, where you can easily add your organization and browse through other organizations. Like Barry also mentioned in his presentation, the different companies that he interviewed, we will also add them here so that you can also browse through those. And all of this, again, or once you create an account, you can easily access all of this resource and also input your own data to them. So going back to the topic for today, the productive use of energy, in which solar irrigation falls under. So what we have done is we have also set up a hub where we have then compiled all the information related to solar irrigation at this point. So that means what are the different information? That means all kind of background information about what is solar irrigation, as Mario already talked about. We also have articles explaining that more in detail if you would like to go back and read it later. The study that Barry just presented, we also have them in a detailed form on the hub. So for example, where you see my cursor right now, it should say market assessment for solar power irrigation. There you have individual chapters where you can again go back to and have a look at all the different points that Barry talked about in his presentation. And then along with that, we also have additional technical and financial aspects. Information about how do you select a good PV module, how do you size a tank, what is groundwater management, how do you calculate water demands, and all other tools that you could use if you were going to do SPIS planning. And also some of the tools I'm going to briefly introduce today, but all of them will be linked on the hub so that you can look at them at your own time and go through them at your own time. So I hope I've convinced you up to now and you're super psyched up to register on Energypedia, and you might be wondering, so Renisha, how do we contribute? We are all psyched up and ready to contribute. So all you have to do is register on Energypedia and you then join the Mozambique Off-grid Practitioners Group. I'll show you shortly how to do that. Shout out to everyone who has maybe a case study that they want to showcase, or they want to collaborate us on upcoming webinars on different off-grid topics, like my colleague Fernanda already mentioned at the beginning. So you can reach out to me, and we also have a template, a case study template, if you'd like to have one. So you please feel free to reach out to me, and we will then sit together, and together we can design curated products and have your contribution put up on online. And also, I showed you a range of chapters or articles on different topics related to solar home systems, solar irrigation. So if there's anything that you feel like I have additional resources that I would like to add up to, or Renisha, maybe there is something that needs to be corrected, I encourage you to then edit those articles and then add your information online. And exactly how you can do it, for that we have a webinar coming up tomorrow. My colleague Fernanda will talk more about it later, and in that tutorial, she's going to show you exactly how you can add your information, how you can create new articles on Energypedia, and so on. And if you also would like to just have one-to-one tutorial, you can also always write to me at the address mentioned in my screen right now. So moving forward, as I mentioned, I wanted to quickly show you how to register on Energypedia. So as you can see on my screen, if you go to www.energypedia.info or use the link that I put on below where my cursor is right now, you would come to this page, and there on the top where I'm putting my cursor, there is this page called Register and Contribute. And once you click there, the image on my right side of my screen, that's what will pop up. It's a simple formula where you have to put in your name, your email address, and here it says main areas of interest, and there you would have to choose Mozambique Off-grid Hub so that we know that you are interested in the Mozambique group. And then you just go down and put a bit of bio information about yourself, and then you click on request account. And then within a few hours, then we will grant you access, and then you can use all the resources on Energypedia. So now I want to move to my second part of my presentation. So in my second part, I want to focus on what are the tools and resources for SPIS planning. So again, quoting my previous presenter, both Marian and Barry, that when we talk about SPIS planning, we really have to think of the value chain. Like Mario mentioned, that you have to think about your groundwater source, your crop requirement, then you think about your finance aspect. So that means you also need a tool that is kind of going to help you with each one of these aspects. So what I have done today in my presentation is try to pick 2 or 3 tools which are hosted on Energypedia but developed by our partners. And I'm going to quickly talk to you about these tools which you can explore at your own time. And all of these tools are free and open source. So you can use them and then kind of see how do you want to do your own SPIS planning. So the first tool I want to quickly introduce is it's called Toolbox on SPIS, Solar Powered Irrigation System. It is developed by GIZ Water Energy for Food program and is currently hosted on Energypedia. So this is a very much comprehensive tool because it's designed for small-scale farmers, smallholder farmers. And the good thing about this tool is really that it is very comprehensive, and it really gives you the idea from understanding what is a solar power irrigation to all the way how do I do my crop calculation, how do I do my finance, how do I design, what is my pump sizing, and so on. So it has a lot of Excel tools on each of these topics that you can see on my screen. And then you can kind of go through each one of them and kind of see which one would be the best one for your own calculation. Today, because of time limitation, I cannot go through all of them. I'm gonna just pick up 2 or 3 just to complement what Maria already mentioned in her presentation, and then also to show you that. So for example, Maria also talked crop water requirement. You need to know what is the demand. So with crop water requirement, you need to know what kind of crops, what is my climatic conditions, what kind of water resource I have, what kind of how many seasons I'm going to farm, because with the more seasons you have, the more water you require, maybe per season. All these different factors, what is the water demand of my crops, and so on. So this is one of the tools that is part of the toolbox on SPIS, which has an Excel formula where you could then put up all of this different criteria, like your location, your crops, your season you are farming, and it kind of gives you an estimation of what could be a water demand for the hottest month, which is for what you would mostly size your system. So this is one tool I wanted to quickly give you an intro to. The same toolbox also has the pump sizing tool. So remember in Marian's presentation, she talked about this pumping height, how that influences, and all the different factors. So again, in this pump sizing tool, you would again take all of this factor, you'd plug in what is my water demand, what my pumps, my solar panels that I'm using, my pumping diameter, and all of those information to kind of get a rough estimation of the size of the pump that you most probably might need. It also allows you to choose what kind of water resource I'm looking at, groundwater or some other kind of resources, and so on. So again, please have a look at both the tools and other tools at your own pace. Moving forward, I wanted to show another toolkit. It's called Solar Pumping Toolkit. It is developed by the Global Solar and Water Initiative. And again, this is also designed to be very comprehensive. So you have information from the basics of what is solar pumping to all the guides to, again, doing cost comparison, checklist, and so on. So again, have a look at both the tools. For example, one of the tools just to introduce as part of this toolbox would be cost comparison, which is really a big factor. How do my solar powered system compare to a hybrid system? How does it compare to other kind of system that could be diesel system? So this toolbox has like individual Excel sheets or Excel tools that you can fill in, and you can do the cost calculation. So just to give you like a brief snapshot, this is one of the tools that is part of that toolbox. I encourage you to click on that link. Once we share the presentation, you'll have the link, and then you can kind of go through that link and then kind of see which tool would be the best for you, because both of this toolkit has a lot of different individual Excel based toolkits. So you can choose what is my demand, or what am I trying to calculate, and which one fits the best. And one more thing that I wanted to point out, which is often, I mean, Marian also briefly talked about in her presentation, but we don't pay much attention, is also water tanks. Water tanks can be an efficient way of meeting your demand without having to oversize your systems. And it's always a tricky question, how do I size my water tanks? What are the factors? Unfortunately, I don't have any Excel formula or Excel sheet I could give it to you. But I wanted to quickly also put up some resources that you can go back to and kind of read if you are looking into how to size your water tanks. For example, the guidelines that you can see on my screen, which kind of says how should be the tank size, for example, with generator 0.5 to 1 times daily water requirement, and so on. These are guidelines mentioned in the book that I just use as a reference. Along with this, there are other guidelines saying you need to look at your hourly supply versus your demand, and then kind of map the clock, and then your water tank should meet the difference. So there are like different kind of formulas to do this. Which again, today I don't have the time to go through everything, so I have linked them here. So if you click on that link, it will take you to an article which would explain all of this. There we have also put up a webinar that we did where we talk exactly this topic, how do you do water tank sizing, and we had an expert talk about in detail. So I hope that all will be useful to you, and that's the resources that I would highly encourage you to have a look at it whenever you have time at your own pace. So with that, that was my short presentation introducing you the hub, introducing you the tools. I hope you liked it. Before I pass you back to Fernanda, I want to quickly pull up my my live screen. So I hope you can see my complete the screen that I'm showing right now. So I wanted to show you the hub as in live. So I'm just going to give it a few seconds to load. I hope it has loaded on everyone's screen. So I just mentioned before Energypedia. So if you click on energypedia.info, this is where you will land up. And here, if you can see my cursor, that is where you would click on to go to and register. So once you register here on the right side where you can see actually my image, that's where a login information will appear. But since I'm already logged in, so I must be, so you can see my profile. And if you go below, here is the Mozambique, excuse me, Mozambique Off-grid Knowledge Hub. And if I click on it, I will come to this page, which has then all the information about the hub, the information that I just presented, and you can then browse through by clicking any of the topics. So if you were interested in, let's say, any of these articles, you would just click on it, and then it will go to an individual article page. If you were interested in knowing more about the productive use resources that I just introduced, the solar irrigation resources, you would click on this icon that says productive uses of energy, and then you will come to this hub. I hope it's loading for everyone. And here, under here, you can find different articles. Like, for example, if I click on any one of them, then our article will appear here, which would then have all the information in this format. So I do encourage you, highly encourage you to have a look at the hub, click around, explore it. If you see anything that you think it's not correct, please do reach out to us. We welcome any and all feedback. And yes, all the information that, as I mentioned before, is already put up. So including the tools that I talked about, all of those are linked here. So you can definitely have a look at all of those. And if you have any questions about any of those things, please do always feel free to contact us. So with that, Fernanda, I think I'll pass it back to you. And thank you so much.
Thank you so much, Renisha, for your presentation and for showing us the hub. I will now take control again. Yes, thank you so much. And I would like to remind all our viewers to please send us your questions. Remember, if you are in the GoToWebinar software, you can send your questions through the questions tab. And if you are in the blue button, just type your question in the chat and we will address it now for the Q&A. So before we go into the next Q&A, I would like to launch a second poll because I would like to know if you would be interested in a follow-up webinar. So I will launch the poll at the moment. For those of you who are in the big blue button software, you should be able to see the poll already. And for those in GoToWebinar, here is the poll. So would you like to see a webinar more focused on the technical aspects of solar irrigation, of the financial aspects of solar irrigation, or both? So I will give just a few more seconds to collect your answers. And now I will close. So the majority wish to see both topics addressed, with a little bit more leaning to the financial aspects. So that is good because during our next webinars, we will have a follow-up webinar on SPIS on February 16th, where we will address both of these aspects during an interactive deep dive discussion with the SPIS experts. So you can save the date and stay tuned for our communication material. I see that in the Portuguese channel, as well as in this channel, the majority leans to both. Although there's a little bit more people interested in the technical aspects. So as I said, it's good that we will address both and we will find a balance between both topics. So thank you very much for sharing this with us. And yes, just stay tuned for our communication material. As I said, it would be on February 16th of 2022. So now for our Q&A session, I would like to ask all our experts to turn on their cameras and unmute themselves. So Renisha, Barry, and Mariam, please turn on your cameras. I will turn mine as well. So I would like to start with the first question for Mariam. One of our viewers would like to know how many panels may be needed to mount for a system in an area of 1 hectare.
It completely depends on the water depth that you're going to have and the flow that you're going to need. So it's, and again, I would just like to highlight that you, again, need to refer to your water source, because maybe you want to irrigate 1 hectare, but if the water is very deep, or if there is not a good recharge in your source, well, you will need a lot of power, but you also might not be able to irrigate 1 hectare. So I'm not really able to answer that question. The calculation could be made easily. We're also, we developed an app to select a solar pump, and we're now improving it where we will include the dimension of the solar panels there. So hopefully it will be online in the coming months, and then it will be very easy to calculate, but this is too little information.
Thank you very
Fernanda,
much.
Maybe I can add a little bit on what Marian said. I would also encourage our viewers to have a look at the toolbox that I just showed, because exactly what Marian just mentioned, it has the steps, like you would do your crop water requirement when you put in more details, apart from just the 1 hectare, like what kind of crops, what kind of groundwater resources, and that kind of gives you the data that you plug in then on your pump sizing, then your panel sizing. So it kind of follows a chain. So I do encourage her or him to kind of have a look at that, and most probably that would be also really helpful.
Okay, thank you very much for your answers. Yeah, with that cue, I would like to ask another question that we got from the audience, asking what are good software's recommendations for dimensioning solar irrigation systems?
Sorry, I didn't hear the beginning of the question. Sorry.
Yes, what is a good software? What is a good software for dimensioning a solar irrigation system?
I personally, maybe Bere, you know something, but personally, I don't know any software. Bere, do you want to answer that?
Yeah, well, I would look what is available, which brands are available where you are, because the main solar pump brands have their own very detailed software to make these designs, and they can do it for you, the suppliers. So the Lawrence, Grundfos, and so on. And then, yeah, other resources can be found on the Energypedia and Practica websites, but you will need to do a bit more calculations yourself.
Sure. And then from my side, if you are looking for small scale sizing, then the tools that I mentioned today would really help you. Below, maybe let's say 2 to 3 acres, or maximum 5 acres, I think. Above that, I think the tools, I have to see them, but up to that, they will be really helpful. But if you are doing a little bit larger field, then also there are tools like PBSS, which is a bit more complex and needs a little bit more understanding, but you could also explore those ones.
Okay, thank you very much. So for our next question, this one is directed to Barry. Barry, you were talking about the payment options for the pumps. So could you explain a little bit more of the form of payment suggested by the farmers?
Well, we did not interview farmers in Mozambique, so we could not ask them directly for their preferences. But what I could say in general is that farmers are very reluctant to take risks and to take loans that come with a collateral and that could mean an important loss for them if, for one reason or the other, they don't manage to produce a lot or sell for a good price. This is why we recommend to look more into the asset-based financing, because then the biggest risk is to lose the pump that they got and not losing other assets that they have themselves, that they possess. So that's the general answer I could give.
Thank you. That is also a good cue for our following question. So this question was for Marian, but of course anybody can answer if you have anything to add. So Marian, you mentioned there's the risk of theft for solar irrigation systems. So do you know any ways to protect the systems and how to reduce this risk?
I would say it also depends on the type of pump you're using. Some pumps are small and light, and it's mostly suction pumps actually, and you can use them in your field during the day, and then you can pack everything up and bring them at your home, where it's usually more secured. But other pumps are more fixed installations and they have to remain in the well or the borehole. I think a borehole is more easily secured with a protection on it that you can lock. A well will be more difficult, but I don't have a specific answer again, because it will depend on the water source and the pump that you're using.
Thank you very much. And so it's good to know that there is different ways of protecting your pumps and also taking them away when you don't need them for some cases. And so our next question is to everybody. So our viewer said, I would like to know if solar pumping can be done in water holes or just surface water, because they seem to be already using the pumps, but they are using from the national grid and they would like to change to solar. So they want to know if they can also use it for water holes and not just surface water.
Water holes? What is this? Bere, do you have an answer? I'm sorry.
So for
Maybe open wells?
Yes,
I
for
think
an open well.
wells, open deep wells. So that would be the.
Yeah.
Sorry, I was just going to say deep wells. So that would be not the surface pump, but the submersible pumps, which they could use in this case. Because with surface pump, you can only have certain pumping height, but with submersible pumps, they have more power and they can actually pump water from deep wells. But then again, I would say groundwater management would be a big topic when you are pumping from deep wells. How much do you pump? But maybe Marian, you want to add something to
that? Well, submersible pumps can also be used in open wells. It depends, of course, on the water quality, but there is no strict reason why not to do that. And suction pumps, yes, their capacity is limited by the amount of water or the water column that they can suck. It's like a physical limitation, but they do have a lot of power if you to push it up in the field. Or I mean, it also depends, of course, on the type of pump, but yeah.
Good, thank you. So our next question is, does the irrigation potential of an area depend on the quality of the solar pumping system, the amount of water available in the soil, or the amount of energy from the sun's rays? What are the conclusions? What is the potential for solar irrigation in Mozambique in this case?
I would say all of the above. Because we need, well, as Marian highlighted, we need enough water in the water source. That's where it starts. We cannot irrigate more than the amount of water that is available. Sunshine is not the limiting factor because you can always add more panels and then in that case catch more sunshine and increase the energy input to your system. So that's not the limiting factor in Mozambique. It's really the available water source, and of course the amount of money you would like to invest in your system.
And one more criteria I will add to that would be also the quality of your swell, because I've also seen in field experience that when you use a lot of chemical fertilizer in your swell, it loses its capacity to retain water. So when you have a good quality swell, once you do an irrigation, it's tend to retain that water for a longer time. That means the frequency of the number of times you might have to irrigate kind of decreases, which decreases not always, but it sometimes could decrease the amount of water that you might need to pump. So that also kind of falls into that bag.
Good. So also around the same topic, what would be the regions or the areas with the best environmental characteristics for solar irrigation?
Depends how we define the environment. I always say that we should go to the areas where there's most knowledge and market development already. I'm not sure that, I mean, that's also part of the environment, right? I'm not sure if that's what was intended.
Of course.
But it is, yeah, it is the areas where we see the biggest potential.
Yeah, and I would add to what Berry says that we also see a complementarity between solar irrigation and petrol irrigation, which is usually with suction pumps that have a larger power, while solar irrigation, you can use submersible pumps that can pump at larger depths. So it's a potential that it has that can also be exploited, but it's not the only factor.
And in fact, just to add to that, the fact that farmers are already there irrigating means there is water, means there is a market, means there is fertile soils. So if that's happening, all the environmental factors are there.
Good. So you would say that if there is already irrigation happening and there is already a market, and then it would be easier to implement a new option, for example, solar irrigation. Correct?
Yes, easier or maybe even essential, especially if we're asking farmers to pay back over time.
I think I completely agree with Barry on that point, which we sometimes forget that someone has to pay for the system. So that means you also need a market where they can sell the produce and be able to pay for that system. This also has to, this financing component also has to be an integral part of that environment when we talk about.
Good. So thank you very much. So for our next question, this one is directed to Barry. So you mentioned that only a percentage of the suppliers offer user trainings. So how do the farmers who use these pumps know how to operate, assemble, and maintain the pumps? Do you know if they have any kind of extra training from the suppliers, or do the suppliers do that by themselves? And how do they ensure that the farmers use them appropriately?
Yeah, so in an ideal situation, 100% of the suppliers provides training to their users, to their clients. Maybe this is the problem. Farmers are not always the clients. Their clients are often the NGOs or the institutions promoting these pumps, and farmers are seen as beneficiaries. And therefore, not all suppliers pay a lot of attention to training these beneficiaries. But I think it's good for everyone to realize how important this is, to demand a simple, because it can be very simple. It can be done in 15 minutes or half an hour. The simple training on how to operate the pumps and how to do basic maintenance. And maintenance is limited for solar pumps, so that's possible to do. And we have seen in other countries, we have experienced that the major reasons for failure are very easy to prevent if only a clear explanation was given at the time of handing over the technology to the farmers.
Yes, you're absolutely right. I agree. It's very important to have proper knowledge, especially at the beginning, and then continue the training to all the users of the system. So that also leads to my next question. So this also goes to either of you. So I would like to know what are some of the malpractices that you have seen both while selecting a pump and maybe installing the system and maybe choosing the wrong system from the beginning, or other malpractices that are related to not enough training. So whoever wants to begin.
Malpractices. I think I can start from a recent experience, because last week I was in Ghana on a demo field, and there we saw an enormous system with 12 330-watt solar panels, big, nicely done. But still, the amount of water that came out of the source was came out of the pump was very small. Why? It was because the system was too big for the borehole, and as a result, there was an enormous drawdown. The water went back to 45 or 50 meters, which is, if we have paid attention to Marion's presentation, it's all additional head, and you need all these panels were needed to overcome this large head and not to have a larger amount of water. We saw that when we covered half of the panels, we had a we had a bit of a smaller output, but not much smaller, just because the drawdown in the well was a lot less. So maybe it's a very technical answer, but it's good to make sure that the pump capacity and the borehole capacity match. Because because if you have a bigger system, you can invest a lot more, but you don't benefit from it if the borehole cannot provide the amount of water.
Exactly. So yeah, this goes back to the to what Marion was presenting, that there has to be a balance between all the elements before choosing the right system from the beginning. Also to avoid losses of cost losses in the end, to have to replace the whole system or just to run with an inefficient system. So the next question goes to Renisha. So one of our viewers wants to know, what is the benefit to have a water tank for irrigation? Why not pump straight to the emitters? Why is the tank necessary in some cases?
So I will quote Maria on that. It depends. That's, I think, the answer going to be today. So for example, if you have crops that require early morning watering or early evening watering, then you might not have the irrigation might not be the level to pump water and do that early morning irrigation. At that time, it is beneficial to have a water tank, because then you can just use the water. It is available also on cloudy days. It also gives you more flexibility. For example, you don't instead of having a battery as attached to the system, you could think of having a water tank where you pump the water and use it whenever there are cloudy days or where the power is not enough to pump the water that you need. So that will be always an added benefit. And also with the sizing of the system. And here it's also very much tricky. I think Marian and Bailey already talked. There are a lot of parameters to think about. But also you could add one more parameter, that is the tank, to it, and also think about how to size your system, not always going for oversizing, but also including the water tank so that you can kind of reduce the cost of oversizing your system. Again, this is very much context-based. I will never generalize it for anything. It is very much, what are you trying to do? What is the actual demand for what kind of location? And does adding a tank really help you, or is it more better for you to not have it? So you really need to contextualize it on the particular field you're operating on.
Good.
If I may add to that.
Yeah. Yes, of course.
Because I think the tank is only necessary if you really want to irrigate early or late in the day. It's not required for the functioning of a drip system necessarily. But it is a very common myth that you cannot irrigate, that it's bad to irrigate in full sunshine or during the day at noon, for example. We've looked into this a lot because, of course, when you promote solar pumps, you know it comes with the condition of irrigating during the day. And some professors of Wageningen University from the irrigation group, they said the only problem is when you have crops like lettuce that, for example, get spots or marks which makes them look less nice and appealing. And therefore it reduces the price that farmers can get. But for most crops, this is not a problem. So yeah, it's I would like to say, keep in mind that for the majority of the crops, you can irrigate during the day without major problems.
Okay, and also, if I am correct, there's also different types of irrigation that is not just by sprinklers. So in the case of those crops, there would also be other options without damaging the leaves, correct?
Thank you very much. Yes, important addition.
And
good, another thing
also,
to keep in mind.
Just a tank, when we're talking about the water tank, many people visualize it as something elevated, but that's not necessarily true. A tank doesn't have to be 5 meters high. It can also be close to the floor level or just a little bit higher, 1 meter, and it works better. And this is also important when designing your system because it will have an impact on the head, so on the amount of water that you will be able to bring to your tank.
Good, thank you. Yes, I believe that is maybe a common misconception, especially maybe from people who have never seen such tanks. And I think the first image is, thinking of a water tank in a house, on top of the house, or something elevated, and that's not necessarily the case. So this goes to the next question, which can already kind of be answered by what we've been talking about. It says, what are the alternatives for solar water pumping in times of days of low sunshine? So one would be, of course, having a tank, but what are other alternatives? So is there any hybrid systems that work better in regions that have low sunlight, or what would be another option?
Yeah, there's a few pumps on the market. That's mainly the small pumps for small farmers that come with a manual handle to power it, but that's hard work. So that's only for very small scale. The main recommendation that I could give is to add panels. Nowadays, panels have become a lot cheaper than before. And that's a way to really increase the time span of your maximum, of your peak sunshine hours, let's say, that you have available. So by adding panels, you can increase the time during the day during which your pump functions fully.
Good, thank you. And so for our next question, so this one is for Renisha, or in general, it's for the use of softwares that calculate the water requirement. What is the source for the meteorological data for crop watering requirement? Are they available countrywide, or are they standard units?
Yeah, Barry, do you want to say something?
Yeah, well,
Okay.
this was complicated, I think, in the past, but nowadays on Aquastat, they have a very user-friendly portal where you can see per month the water needs depending on your location. I can look for the link if necessary, but it's very user-friendly.
It's called Climate Info Tool. I think if you Google that, you'll find it.
Or we'll share it in a link in the documentation.
Yes. Yes, we will share this in our documentation. And what was the other one, Barry, that you mentioned? Aquastats?
Yeah, but that's the same, actually.
Yeah.
Okay. Okay, perfect. Thank you very much. So the next question is more about the loans. So it's a good question. So are Mozambique microfinance institutions prepared to offer loans, especially for SPIS systems? Well, SPIS. Does technical assistance and financial assistance cooperate to offer service packages? What is your knowledge on this?
Most are not because of the high investment. So most MFIs, they're used to provide agricultural inputs to farmers, which have a lot lower cost and a lot and a duration that is a lot shorter, only 1 season, compared to the payback time of equipment, solar pumps. So the large majority does not provide such funds. At the moment, the BCI has launched in collaboration with UNIDO a package, a fund that is specifically for productive use of renewable energies, including solar irrigation. So this is not even an MFI, it's a bank. So that is very nice. This is a solution for the higher segment of farmers, the more commercial farmers, because it does come with requirements in terms of, I think it's a 25% upfront payment, it's a business plan, and things like that. So but that's, I think in general, for banks, this is always targeting the higher, more commercial segments.
Yes, so there is a little bit more to be done for the smaller scale farmers. So thank you. So we're running out of time, so I have time for one more question. So one or two more questions. So this one is for Marion. Is there any risk of wear and tear on the pump and other components when they are moved frequently?
That's a good question. I'm sorry. I'm gonna say it depends. I'm sorry, it has been my motto today. With suction pumps, light and transportable, I don't really see an immediate risk of wear and tear, but if you're trying to transport a pump that is meant to be more fixed, I do imagine that it would be more damaging. But I haven't really seen or had any experience with that. Barry, did you?
So the wear and tear of
the components while moving them. Mm-hmm.
In moving them, well, the main thing is panels that fall down and break when you move them around, and there's no warranty that covers it. So that's the main thing to be careful about.
Okay, so yeah, so those would be the most fragile parts of the whole system, and yeah, if they are not guaranteed, well, if they don't have a warranty or any protection, it would not be wise to move them around too much, correct?
Yeah, you need to be careful because no warranty offers such kind of mistakes or accidents provoked by the user.
Yeah, which is why it's important to make those considerations from the beginning and make a wise analysis before selecting the appropriate time. So that goes back to the initial part of this discussion. So, well, since we are running out of time, I would like to thank you all very much. Thank you, Barry, Marion, and Renisha for this insightful discussion. And thank you, everyone, for sharing all your questions with us. Unfortunately, we cannot right now, but we will address them via our discussion groups that Renisha presented earlier. And yes, our experts and everybody who joins can actually answer. So it will be an interactive way to exchange information. So thank you all. And now I would like to ask another last question to our audience, which I will launch at this moment. So I would like to know if this webinar was helpful for you, regardless of your level of experience. I hope there was a little bit of something new for each level. So I would just give some more seconds. And of course, also for our viewers in the platform and Big Blue Button, please send us your votes, and I will give you just 2 more seconds. And thank you so much. I am glad to see very positive results. And this is very good because, as I said before, we are going to have a follow-up webinar, and we will deep dive into into these topics in the technical and financial aspects. And this is also important for us because we will have future webinars in next year on different topics. So if you like this webinar and you liked our past webinar, then you can expect more on other topics. And if you haven't watched the other webinar, you can also see the recording in our page. So before closing the webinar, I would like to invite our viewers who are interested in becoming part of the Mozambique Off-grid Knowledge Hub to join us in our tutorial webinar on how to share your knowledge in Energypedia. This webinar will take place tomorrow on December 16th at 10 a.m. Mozambican time. So that is GMT +2. And it will be held in Portuguese. You can register via the link shared to you via the chat. And this is also the link that is shown right now on the screen. As I said, it will be in Portuguese. So if you are interested in a tutorial in English, we also offer these tutorials regularly. So just stay tuned for our next tutorial in English. And all the webinar documentation for today, the recording, the presentations, and more resources will be available in our webinar page shared in the chat. And these are the two pages. So the one on my left is the webinar landing page, as I said, where you can find all this information. And the one on the right is our discussion page. So this is where all the questions will be posted and where you can share your thoughts and your experience. Don't forget to register in Energypedia to be able to follow the conversation, and don't forget to register as well to the deep dive session on SPIS on February 2022. Like I said, all this information will be shared with you as well in a follow-up email. So we would like to remind you as well that there is this renewable energy master courses at the UEM. There are currently 70 scholarships available right now, a 50% of tuition fee, and they offer a master course in science and technology of renewable energy, and there's another one in management of renewable energy systems. So just register. If you're interested, there's all the information. And I would like to thank one more time our dear speakers who gave us an insightful discussion, as well as our attendees who make this kind of events possible. I would like to thank GIZ, Amer, and of course our colleagues in Energypedia and Practica Foundation. We really hope you enjoyed today's webinar, and if you have any feedback for us, you can answer the survey at the end of the webinar or send us your comments to our email, info@energypedia.info. Once more, on behalf of Amer and Energypedia, thank you very much for your presence, and we hope to see you soon. Stay safe and have a good day.